Today we're tackling a Leetcode problem called Zero Array Transformation 2. The problem provides us with an array of integers, and a 2D array called each query represents an operation to decrement values within a specific range in by at most a specified value. Our goal is to find the minimum number of queries, applied sequentially, required to transform into a zero array, meaning all its elements are zero. If it's impossible, we return -1. Let's start by outlining the first approach. We'll be leveraging the concept of a difference array combined with prefix sums. The core idea is to iterate through the possible number of queries, from 1 up to the total number of queries. For each we simulate applying the first queries to a copy of the initial array. Using the difference array to efficiently update, we create temp_diff, copying over values from diff, and for each k queries, we find the value to reduce by, capped at 0 for j, in range L to R. We then define prefix_AR, where we get each prefix array element by calculating nums plus temp_diff. After we build the prefix_AR, we check if the values are less than 0 and return false if it is. Finally, we check to make sure that all values in the prefix_AR are 0. If they are, then return k. If the loop completes, we return -1, indicating that it's not possible to make it a zero array. Now let's optimize the update process. Instead of iterating through the range for each query, we utilize the difference array's properties. We decrement temp_diff at the start index by quivdard. Then, importantly, we increment temp_diff at index quivdar plus 1 foot by only if plus 1 foot is within the bounds of the array. This cleverly encapsulates the range decrement. Inside the loop, we accumulate the differences, temp_diff plus equals temp_diff dash 1. Then add this result to the nums value to calculate the prefix underscore arranged by Array Prefix. This builds the prefix sum efficiently. The rest of the check logic remains the same. We check if the array has become 0. Now let's see how we can improve this further with binary search. We know the answer, which is the number of queries, lies between 0 and the total number of queries. This is a perfect scenario for binary search. We define a check function which is very similar to the prefix sum calculation we did before, but instead of returning true/false if it is the answer, it returns true if the array can be zeroed after k queries. We use this check function within a binary search. We initialize left to 0 and right to the length of queries. We repeatedly calculate the midpoint. If check mid returns true, meaning the array can be zeroed with mid queries, we update ans to mid and try to see if we can zero the array with even fewer queries by moving right to mid -1. Otherwise, if check mid is false, it means we need more queries, so we move left to mid +1. Finally, we return the value of ans. Here's a breakdown of how the check function is implemented. The check function takes an integer k as input, representing the number of queries to apply. We initialize a difference array diff. We loop over first k queries to change the diff array. We decrease the left index by the query's value. If r plus 1 is a valid index, we increase it. Then, we calculate the prefix sum array. After calculating the first element, if it is less than 0, we return false. Then, in the loop, we calculate the actual change at the current position by adding previous difference value, diff, plus equals diff 1. Then we add this accumulated difference to the corresponding element in the original nums array. If any element is negative, we know it cannot be a zero array with k queries, so we return false. Finally, we check that all the elements are 0. This is the binary search part. Left starts at 0, and right starts at the total number of queries. Ans is initialized to -1. The while loop continues as long as left is less than or equal to right. We calculate the middle index, mid. We call the check function with mid as the number of queries. If check mid returns true, we update ans and move right to mid -1. If check mid returns false, we move left to mid +1. Finally, we return our answer, ans. Let's talk about the complexity of the binary search approach. The time complexity is big O of n multiplied by log of m, where n is the length of the nums array and m is the length of the queries array. The binary search itself takes log of m time, and within each check, we iterate through the nums array, which takes big O of n time. The space complexity is big O of n, as we create a difference array and a prefix sum array, both of which are proportional to the size of the input array, nums. That covers the Zero Array Transformation 2 problem. I hope this explanation was helpful. Let me know in the comments if you have any other Leetcode problems you'd like me to cover in this series. Don't forget to like and subscribe for more algorithm explanations. And if you'd like to help me continue making these videos, you can donate at buymeaboba.com. The link is in the description. Thanks for watching.